Good afternoon, everyone. I want to thank you for joining Dawn and I. A few housekeeping items. As I walked around, I saw lots of cell phones. Just be aware, if I hear a cell phone ring, you will be a target. I've got the podium, and I won't appreciate it, no, Dawn, and we will certainly go out of our way. The original presentation had 170 slides. It was very well received, but I realized I can't talk slow. I'm really sorry. I haven't talked slow all my life. I will do my best to slow it down. We did eliminate about 40 slides. So we've got about 35 seconds a slide. Questions will be at the end. We'll walk outside. We'll answer any questions you have. And let's get this going. And we're confined to the podium, which you're probably lucky, because they are recording this. So, Mr. Sullivan?
So which one of us is going to be the first one to walk off the stage here by accident?
I'm thinking you're right.
I'm Don Sullivan. I'm the Product Line Marketing Manager for Business Critical Applications and Databases at VMware. I've been here about 5.5 years. I have a lot of Oracle background. I'm an Oracle Certified Master. And all that other stuff up there. So there you go. Now, he put all that up there. I don't do it.
So I'm Mike Corey. I've been doing Oracle databases since version 3. I'm an Oracle ace. I'm a recognized VMware vExpert. I guess I have the commercial on my shirt right now. And I'm also a SQL Server MVP. I'm the original Oracle Press author. My latest book is How to Virtualize Databases on VMware. We're also both columnists, so we're pretty active in the community. This session is going to do something a little different. We always have to give you a plug for our books. So on the right is the SQL Server book. On the left is the Oracle book, and to be in balance, we both suggest you buy my book and Dawn's book. Also, I have a co-author in the room, Mr. Webster. You want to stand up for a second?
Yes, we still recognize him, even though he works for somebody else these days.
Yeah, we're not allowed to mention the company.
Yeah, we're not.
We wouldn't give you a plug, sorry. It's not going to happen today. So we're going to do something a little different. We're going to talk about virtualizing databases. We're going to have a heavy emphasis on SQL Server and some emphasis on Oracle, but all the lessons, all the rules will apply to any monster VM, anything that's going to take a lot of resources when you virtualize it. A lot of the data came out of the database workshop, which was Dawn's idea.
Well, we have an entire program in which we recruit the top experts in various different database disciplines from all around the world. We bring them into Palo Alto for 3 days of executive welcomes, labs. We wine and dine them. We have a lot of fun, and they come out being completely absorbed in the ideas of virtualized infrastructure for databases at every possible level. That's the whole point.
And what are you going to be doing for workshops next year, I heard?
We got 4 of them we're going to have. We're going to have one for big data. We're going to have a SQL Server workshop that follows up on the ones we've already done in Palo Alto, but we didn't do it in Bulgaria. We have an Oracle workshop for Oracle experts, and an SAP workshop that's going to be in April.
So if you're interested, you feel that you're at the top of your game, please submit your name.
Got to be a very public figure and very open-minded to the message.
Okay.
So the whole idea of virtualization is very similar to the concept of cell phones in the sense that we don't really care what actual cell network or cell we're actually connected to, assuming that it actually works. We can seamlessly transition using our cells from one cell site to the next without even knowing it. And that's the same idea of the abstraction of virtualization.
So same concept as your cell phone. Do you really care what physical server your database is on as long as it works? Do you really care what cell phone conversation you're having as long as it's working?
So what this particular slide is depicting is the incredible adoption rate and the acceleration of the adoption rate that we have been able to amass in terms of data, both from internal surveys, this is called the Core Metrics Survey, as well as external surveys that we've done through user groups such as the the Independent Oracle User Group and other user groups that we're using.
And so when I hear a vendor tell us how great it's all going, I always kind of question that a little bit. And so I always like to point to some independent surveys. So the Independent Oracle Users Group did a survey, and what you're seeing is a lot of emphasis on virtualization, 62% currently use. What a surprise, 57% of their constituency across the globe is using vSphere. And so you go back to Gartner. Gartner is an independent source. The big dog is vSphere, VMware. They're clearly the dominant player when it comes to virtualization. And in fact, I like the fact that they don't change the OS stack in any way, which means your database will behave the same way it does running on native hardware.
I'm wondering what that other little dot is going up there, but I don't know about that.
Yeah, Microsoft. Oh, I've heard of them before. We used to talk about the right time to virtualize. I think
now
the battle's been won, right? The battle's been won, right? Yeah, you see it, Mike, right? So the rate of adoption, the bottom line is everybody should be virtualizing their databases. So why? We're going to get to the meat of this. This is a good reference slide, talking if you're trying to sell management and you haven't started down that path of virtualizing your databases. You can...
You guys okay? What happened?
Oh, God.
You know, we've been doing this every year for the last 3.5 years, and you guys still buy it. I don't believe it.
The number one reason you get that screen is drivers. In a virtualized infrastructure, you have a small set of drivers that are well vetted, you're less likely to get that screen. You know what they say, if the joke's good, do it over and over and over.
No, we just keep doing it. You keep laughing. What the heck?
That's your slide, my friend.
All right, there are some specific things that we'll talk about here as we move along. But in particular, what this slide is depicting is the fact that there are a tremendous amount of features that are resident in vSphere. vSphere is a platform of virtualized hardware, meaning it's tremendously feature-rich in both the resource management capabilities and the features that allow you to meet your various different SLAs. But that doesn't mean you should use every single feature that happens to be there. We'll see that the various different hot add capabilities disable other capabilities. So just because the feature is available doesn't mean you use it.
And that's a good example. So for example, if you wanted to hot add memory, an Oracle database could never recognize it unless you had pre-allocated it into the SGA file when it first started up. And one thing we're going to say is you're in a shared environment. Oversizing VMs for the possibility up the road that you might need to take advantage of that is going to hurt performance. So making your VM too fat, too rich, hurts performance of everybody. Right? And then the other thing I like to point out is when I was at Children's Hospital in Boston, we used to run Oracle and SQL Server everywhere. And we always tried to standardize, and we never could. Once they get to virtualization was the point that we could start to standardize these environments. And then I always like to stress, vSphere 6 eats monster VMs for breakfast, lunch, dinner, and dessert. It's as simple as that. It's designed to eat monster VMs. So what would you say?
We just ran the capstone session, and the overriding theme is that every application and database in existence is a candidate for virtualized infrastructure. That is simply a factual statement at this point, and I don't need to say anything more about it.
So I used to go to sessions and ask people if they thought their database was too big to virtualize, and I used to get, especially on the Oracle side, my database is too big to virtualize. And so then I started to put out an example of an Oracle ERP system that was virtualized.
This little system.
Right. And I said, are you doing 52 million transactions per day, right? 8 terabyte database, 8.8 billion rows. And by the way, this is a really old slide. And that was done with all the previous versions of VMware, and it worked great being virtualized.
So we ran a test about 3 years ago now in which, well, what we wanted to do is take highly sensitive Oracle real application clusters and use vMotion capabilities on very heavily loaded cluster nodes in this Oracle rack cluster. And so we did that. We took a single rack node, we loaded it with Benchmark Factory with a third-party testing company and Principal Technologies, and we vMotioned one of those nodes. And what happened? Nothing. Okay? Then we got a little bit more intense. We said, okay, let's vMotion 2 of them. Let's go A to B and B to A, and we'll make something happen, and we'll get a false ejection. We'll get some kind of fencing operation, and nothing happened. So then I went really crazy, and I said, we're going to take all 3 of those rack nodes, and we're going to run them in a merry-go-round fashion. We're going to go A to B, B to C, C to A, and we're going to see how long it takes to actually cause this cluster to just blow up. And you know how long it took? Well, we're still waiting. The point is that vSphere creates 100% abstraction between the OS and the hardware. Even with something as sensitive as Oracle Real Application Cluster under extreme load, it's just simply not a problem.
Yeah, I mean, active, fully being utilized, nothing broke. And then I bring out the point. vMotion came out in 2003. It's over 10-year-old technology today. Right? And then I talk about service levels, and we had an interesting case of a healthcare environment where whenever we wanted to take the system down for 5 minutes, they had a problem where their database couldn't use more than 50% of the available CPU. We troubleshot the problem and realized we need to reset the BIOS on the machine. Every time we tried to take the system down, there was never a good time to take the system down. Well, then I looked at the system. It was physical hardware, single node, not even a clustered disk situation. This thing was ripe for going down and never coming back. And so to me, I call it the SLA. Do you have an SLA out there, or does management have an expectation that the environment can never live up to?
Is that your grandson?
Yeah. Because if you do, the elephant's in the room, you've got to have that conversation. And if management says, no, I'm not willing to make that investment, you say, that's all right, then I can't give you the SLA, you're never going to go down. Call it a CYA, cover your rear end, right? Call it whatever you want, but you've reset the expectations, and that's very important. Too often, we don't set proper expectations. And then the other thing is you've got to watch these BIOS settings. There's a number of BIOS settings out there that can cause the system from an energy-saving perspective that can affect lots of aspects of it. And I see this probably about 1 out of every, let's say, 80 or 90 environments where we go in and we look at the physical host and we see that it's not performing as well as it could because I didn't set it up right.
So we have a series of best practices documents. You can get them right off the Business Critical Applications homepage, right off of VMworld.com, and they're for vSphere in general, and then for most of the applications that are really well known.
And there's a great tool you can use on the Windows side. So let's get into this. So the other thing we learned is that in the early days, everybody virtualized things unlike databases. I'll call tier 2 and non-production. Everything worked great. Then they go and they put a database out there, and what happens? All of a sudden, the whole system comes down to its knees. So what we've learned is the lessons you learned in tier 2 don't carry to the high-end stuff. And so we're going to give you a very conservative approach of things that you need to do to get the best performance. But once again, we're going to talk about things like not overcommitting, very conservative. Once you're comfortable with the environment, you can deviate from the rules. So let's start the path of virtualization, right? First thing, read the documentation. Just because it's so easy to install doesn't mean you shouldn't take the time to read the documentation and understand it. And I would ask, of all the documentation, what layer would you probably read most of all?
Me?
Yeah.
Everything having to do with storage.
You got it. And why would you always read storage?
Because 90% of the problems that GSS, Global Support Services, run into have to do with storage. Now, he might say 80% down here, but I say it's 90%.
Yeah. Misaligned, misconfigured, misused,
He
right?
corrected me anyway.
Storage. If you're a betting person, and I love to go to Vegas and bet, storage, right? Second thing, how many people have ever heard of the Professional Association of SQL Server? Or SQL Saturday? Anybody? How many people do anything with SQL Server out here? Okay, free event. They can't charge you more than a cost of lunch, so about $12 US at most. All-day sessions, 4 to 5 sessions an hour, they run all over the world. The best event you can get to learn about SQL Server databases, right? I have a blog, absolutely. I have a lot of stuff. I reference Mr. Webster's blog quite a bit out there. That's a good location. I have useful links. vSphere, as Don said, they do some great stuff. Don, you might want to talk about the next couple of slides.
Well, there's a vSphere blog, there's a BCA blog right off of VMware.com, which is focused on all different events that occur and new information that we need to put out for one reason or another.
And so what you see, lots of slides, the deck's available from the show, giving you links of places to go. These are new white papers specifically around the new version that are quite well done, right? The other thing is when you go down the path of virtualization, you got to have a plan, right? And I would argue the most important thing you can do with that plan is baseline. You have to understand how many resources this critical VM needs to do its job. Too often people skip the step of baselining and they get themselves into trouble. And then you got to think about how you're going to manage this new environment.
And understand the resources from all 4 perspectives. He'll go into this later, but CPU, memory, storage, and even networking.
Right? And so really take the time. How are you going to back it up? And then my favorite is being down 3 days in a row okay? You did have a 99% availability. You met your SLA. How do you think management would feel about being down 3 days in a row? So you got to have a little common sense when you put these things together. And the other thing is garbage in, garbage out. If your physical environment is not performing well and you move it to a virtual environment, why do you think it's going to perform any better? Unless something's changed. I use the example of politicians. If you keep voting the same people in office, why do you expect them to do different things? So there are no silver bullets.
Want to bring up religion next, Michael?
Yeah. And so we call it the IT food groups, which we call disk, CPU, and memory, right, network. And in fact, those are your choke points. If you're having a problem, you've got one of 4 areas to look at to determine the problem. And oh, by the way, you've got an 80 to 90% likelihood it's the storage layer. Right? And when you baseline small sample sets, a lot of the baselining tools look at the system every hour, every 30 minutes. Do you know how much happens inside a busy database in a minute? And so if you don't sample set or baseline properly, you're going to get yourself into a lot of trouble. So as to whatever lowest level you can possibly do, I use an example here of T-SQL for SQL Server, less than a minute. Right? So down, get really low, right? By the core, by the NUMA node, by the drive, whatever low level you can get of information. I want to talk about migrations?
We've got a new program specifically for Unix to Linux that we actually are sponsoring Unix to Linux migrations, specifically because one of the things, through certain partners, one of the things that we have noticed is that through these core metrics surveys that we do is that there is a huge number of customers, and VMware's got 500,000 customers, a huge percentage that are willing to and wanting to and ready to actually move to virtualized infrastructure, but they're still a little bit afraid of certain things. And believe it or not, they're still afraid of performance. And so therefore, we're going to sponsor it for many of these larger customers, and we're going to basically make them into customer success stories. And if you come to VMworld next year, hopefully you'll see them on stage.
So if a customer to come up to my company entirety, and we do obviously lots of virtualization work, the first thing we'd say to them is do a database consolidation project. A typical consolidation is about 60% is what we see when we typically do them. We cut the footprint in half, and then we do an automated migration, because we do them all the time. And the other point here is there's business issues, there's management issues, right? It's a shared environment. DBAs are used to being on physical equipment where they control everything. And now they have to work nice in the sandbox with everyone else. So this is just, these are great reference slides, lots of places you can get good baseline information. There's lots of examples of what we think is appropriate for a database environment.
Yeah, these are the types of things, these next couple of slides, that high-level consultants like Michael down here will use to analyze your systems, to understand the various different performance specifications from a virtualization level.
This deck was really meant to be downloaded and looked at later. Right? Because I know we're moving fast, and I apologize.
It's his fault. Don't blame me. He does this all the time.
I/O is always an interesting thing. You have to understand the I/O footprint. There's great tools out there. Right? There's lots of tools. Slob, Calibrate I/O. Any people ever use Slob? Silly little Oracle benchmarking tool? What do you think of Slob? It's outstanding. I mean, and it doesn't cost anything. On the SQL Server side, there's a new tool, Disk Speed. Anybody heard of this one? It replaces the old SQL I/O. It does a better job with flash environments, which are becoming more and more important. Free.
Flash storage, that is.
Yeah. Flash storage is definitely not free. And so we want to drive home the point of they flunked mind reading. In a shared environment, if you don't communicate what you need to the rest of the team, they're not going to know. So I use the expression, they flunked mind reading. Right? The other thing is when you tell them you need a VM that needs 30,000 IOPS, they give you the VM. Before you go out and install the database, check the IOPS. Because a lot of times they don't listen. Use as an opportunity to educate them and say, no, I did a baseline. Let me tell you what my database needs. And I don't want to be thin provisioned. And when I ask you for 30,000 IOPS, I don't want 6,000 IOPS. Save yourself. So we call it the check it before you wreck it rule.
There is no bigger problem consulting than actually creating a communication channel between the database professionals, particularly Oracle, and the rest of the world, and specifically including whoever is in charge of the virtualization layer.
You know, it's really funny. So I got bought up by a big hosting company, and their standard practice is then provisioning. And it was like, I went, time out. You're not doing that to my customers' databases. So it's really just having and educating them, right? And then there's the old P2V. So I was dealing with a large hospital. They had 2,600 database instances, and they just P2V'd them all over. And then they're having performance problems. Well, first thing is they bought probably way too many licenses, which I'm sure VMware was absolutely okay with. But the second thing is they took all that baggage along. They oversized the VMs and were hurting overall performance. So I'm not saying not to use P2V. What I'm saying is for those critical systems, really recreate the environment and move it over.
Right sizing is everything. Understanding what the real resource requirements are. You could get away with a lot of this in non-virtualized environments, but now, as Michael talked about before, even over-allocation can cause performance degradation.
Now, there was a gentleman in the back I asked to use Twitter, so you just got the quote that I expect to see out there, and I'm going to check, right? Right sizing is everything.
Is that my quote?
That's your quote. No, you get credit for that quote. So this is one I always love to put up there because anybody ever deal with Oracle and licensing? All right, how do you tell if an Oracle salesperson is lying to you?
You recorded, remember?
Yeah, all right, let me say, how do you tell if a politician is lying to you? His mouth is moving, absolutely. Their job is to sell as many licenses as possible, to feed their family. They are incented. So if they can put a little FUD into the situation, like say it's not supported, to get you to choose a different solution, they win. Here's the bottom line. Oracle is completely supported. There's the MetaLink article.
249212.1 since 2007. The only change was in November of 2010, in which they included support for RAC 11202 and above, and that's it. It's the only change.
There's also some great, in my website, my blog, I point you out to some great videos that were done on licensing. The only thing is you need to pay the vendor fairly, but you need to be educated, and you will do your due diligence.
There will be a licensing session tomorrow on SQL Server and Oracle, a full breakout session.
The point of this slide is if you're having a high-end Oracle database, you're having problems, you're not getting anywhere, there is an Oracle team at VMware. Ask for them.
They are an Oracle first team. They come from Oracle support, many of them. They're all over the world. They're in Broomfield, Colorado, in India, in Ireland. They have great accents.
How many people knew there was an Oracle support team? Curious, anybody know that?
A VMware Oracle support team.
Yeah.
Well, you should all know it now because they've been around for 5 years and they're all, you have entitlement to access that Oracle support team as part of your standard VMware support agreements.
I don't know if you can Twitter that. That's too many. But there is an Oracle support team at
It's all yours.
for 5 years. All right. The other thing is there's always this question, how do I set up the database if it's virtualized? I'll give you a hint. Same as the physical. Read the same books, same as the physical. The database and operating system don't know they're virtualized, don't tell them. It was funny, a number of years ago I was trying to get my DBAs, we have about 50 DBAs, handling virtualized databases. This is going way back, and everybody told me all these reasons why they couldn't handle a virtualized database. I went up to one of the CIOs I was very friendly with, very technical, early adopter of VMware, and we put a plan together to just virtualize a bunch of their databases and not tell the DBA team. Then a year later, I went up to them and said, hey, how's it going? Can we handle virtualized databases? They all read me why they couldn't do it.
Can't do it. Can't do that.
Yeah, absolutely can't. Then I explained to them the customer and all the databases that were virtualized. End of argument. We never looked back.
ESXi is a non-para virtualized type 1 hypervisor, meaning nothing changes about the kernel of the operating system, therefore nothing changes about your application or database, period.
That is a really important point. It does not change the operating system. Yeah, yeah. All right, let's talk about design. If you've been in the database arena for a while in systems, you know the difference between OLTP, batch, and DSS. If you don't, you're in the wrong room. Just get out. Leave, right? They have a certain way that they operate. When you put them into a virtualized environment and put them together, they can live together, and as you can see, maximize the use of the systems. Anything else you want to add on that?
Just that a few years ago, we really did have certain hesitation getting beyond, say, certain levels, and those thresholds varied between the different versions of vSphere. In vSphere 6, when we can go up to 128 virtual CPUs and 4 terabytes of memory, and we can easily exceed what's called the NUMA node, which Michael will talk about later, in regards to performance capabilities, we've seen 185% of the actual performance capability of the actual physical cores in a node. We really can go to literally almost infinitum in regards to the footprints of virtualization. So there is no limits anymore.
So just keep in mind, Tier 2 was not built with a database in mind or a hungry application. I'm old school. I like to separate the environments if I can, but certainly licensing is an issue. You can by using things like memory reservations, mixed environments. All right, we're at the halfway point. We're actually on time. So I always like to put a trivia question in there. And so I have to ask, how many people in the audience think it's under? Toilet paper roll. Easy trivia question. And do we have a book we can give them or something?
Only one.
We got one
This
book.
is a binary question, Michael. Anybody want to answer an American baseball question? No, I guess.
Yeah, we usually use baseball. So anybody like trivia here? I like to take a break because it keeps us on time. How many people think it's under? 1, 2, 3. All right, how many people think it's over? Wow, interesting. And how many people could care less? All right. Well, now for something completely different. The proper answer is over. That is the pattern that was applied. So at least if you don't learn anything at this session, you now know the proper way to hold the toilet paper.
All right, I'm not giving all of them a book for that, okay?
Right. This is old school. Should you have more VMs or more database instances, packing them into one VM? I would rather see you take every database instance and put it in its separate VM because you can tune at a VM level. Both strategies are valid, but I like the ability to tune at a VM level. I think it buys you a lot in an environment. Storage, RAID and spindle counts still rule. We are going to flash in a few slides, but the bottom line is a database is about an extension of your I/O, right? Quoting my friend Mr. Webster, so RAID and spindle count still rule. And so then the question becomes, does anybody know where the bottleneck is? Let me ask it differently. Is there anybody that does not see where the bottleneck is here? Because if you don't, you're in the wrong room once again. You need to go to Database 101.
Put your keyboard away and step away from the chair.
Yes. It doesn't matter. Just remember, it really does come down to the physical underlying structure. It's not the inability of the VMs to push I/O through. It's the ability of the physical infrastructure to handle it all.
That's why with vSphere 6, as we've said, all it really required for literally infinite capacity or near infinite capacity is simply the proper hardware underneath it, which is why the Capstone project was so important.
Right, and then there's the argument of VFS or RDMs. They perform about the same.
It has been the case for 5 or 6 years, but I will tell you, as we get into the highest performance types of projects, which again, I'll go back to the Capstone point, we're doing TPCC types of testing on there. To get that absolute 1% extra I/O throughput in general, we will use RDMs for that, but it takes something that has that narrow and extreme requirements to really justify it.
And so I would argue that I would get away from RDMs unless you're in that use case because you want all the advantages of virtualization and future-readying your application. And then there's the thin provisioning versus thick provisioning. I call it the first write penalty. From a database perspective, you would want a thick provision. There's lots of ways you can do this. This is a great reference slide in SQL Server that shows all the places that you can set it and make this happen. And you have to read the storage vendor documentation to see what they're doing. I have a hard time. And then there's some things you need to set. This is a great reference slide that says things you need to set so that this is the case. Let's talk about flash storage for a second, because it's kind of a game changer in some ways. So we ran these workshops, and we brought in a pure storage array the first time on the SQL Server side. We brought in a Tintry storage array the second time. We had a bunch of SQL Server MVPs, and we noticed that they weren't even breaking the machine in a sweat.
They were trying.
Then they decided that they would try to put the machine to work. And they really had a hard time. A group of what, about 15?
Yeah. Yeah, and we had labs that were customized and designed specifically for them to create extreme performance situations, and they're really not able to. All of the rules in regards to database layout change, and to a very large extent. One of the best practices for Pure, as a good example, is that you simply take all of the database files and you put them here. You really don't worry anymore about the various different classic locations. That all being said, again, we go back to doing the most extreme high-performance TPC types of tests, and you still want to get back to actually using some of the classic methodologies. But for everyday usage, even for most high-performance applications, you really no longer need to. We're talking, for instance, with an IBM flash system, specs out at between 100 and 300 microseconds of latency and so on. Okay?
So really, the game's starting to change a little bit. For the average user, you just don't worry about it anymore. And so this is some guidance in terms of, in a traditional storage system, how many temp DBs, they should be the same size. There's a lot of useful information. With the newer versions of SQL Server, it's becoming more efficient, so you see some deviation from those rules. It's a great slide to look at later when you're looking at the over and under. Kind of look at the slide deck and make some choices.
And I'll tell you, those slides can be expanded quite a bit. In fact, in both of our books, there are between 50 and 100 pages on those types of discussions.
Maybe it's a teaser for buying the books.
Yeah, go buy the books.
I have a book don't think we would
tomorrow,
do that
right?
to you,
I
would
have
we?
one to give away. I don't know how we're going to do it, but we have one to give away. Mm-hmm.
You'll have to figure out. Paravirtual driver. Use it. Really simple. 30% reduction in CPU, more efficient I/O. In fact, you used it in Project Capstone. It's just one of those things that works. The other thing I'd like to add to this, and I apologize, I know we're moving quick, is you can have up to 4. It's easy to drink more out of 4 straws than it is 1 straw. Use 4 if it's performance critical.
And remember, those PV-SCSI adapters are for your high workload drives, not necessarily your homes, your C drive, your binaries, and so on.
And then, once again, we go back to this, 80% of your problems have at the storage layer, right? It's really important. If you're having an issue, that's where to look. You want to comment on this?
Not much more, just that we've got a number of different blogs that are referring to the various different aspects of virtualized storage, which is the final step of the full software-defined data center. Remember, that idea is taking the very successful concepts of virtualization for processing and memory that have now been extended with NSX into the network level and then into the storage with vVols, which are total game changers in terms of how you live your everyday life if you utilize them, and vSAN and some other things, vFlash as well, technically.
In fact, it's funny you mentioned vSAN. We have the next...
There's vSAN.
And so we're constantly hearing about vSAN at the conference. It's certainly an interesting technology. I like the fundamental idea behind it. Not sold yet for my high-end workloads. Time will tell.
So there are a lot of sessions. Those sessions are listed. I'm going to make this simple at one point. Some of these sessions are being repeated here in Barcelona. They all were sessions from the San Francisco version of VMworld. As an attendee of VMworld, you have access to the audio recordings and the video, if they were video recorded, for all of the sessions in San Francisco as well. So you may want to actually look at all those if you have a particular vSAN interest.
And yes, you can actually see the missing slides of this session if you go to the US version. So it's kind of like the video, right? You can get the missing 40 slides.
If you want the US level humor.
Yes, and the trivia questions. Mm-hmm. All right, storage layer. We're just driving that point home. Let's talk about the processor. Hyper-threading, right? The bottom line, it's still only one processor. So a common mistake that people make is they count it as 2 when they're trying to figure out their virtual CPU count. It's about a 20% uplift. And so what I would say to you is maintain a one-to-one relationship of vCPUs to CPUs and counting hyper-threading at about a 20% uplift.
Now, what we've seen with some of the projects, again, like Capstone, is we're getting much, much more than that. In fact, with that, we got, in certain tests, up to about a 93% linear scalability when fully utilizing hyper-threading, which is absolutely amazing, and that's a testimony to vSphere.
So the idea behind it is when it's sitting idle, it just flips to the other side and processes more work. So you do get an uplift. And actually, there's a whole bunch of slides that kind of go into exactly how to figure out the proper sizing when you're using hyperthreading. There's always this question of how do you set SQL Server, max memory. I'll be honest with you, this chart works for 99% of the situations. It's what we use in our consulting practice. What's interesting, though, is that we modified this chart from about a year ago to 4 GB for the operating system from 2 GB.
How does an operating system take 4 gigabytes when ESX is 144 megs? I just don't
God,
understand.
when I first started working with Oracle, it fit on 64K of RAM.
Again,
think about that.
ESX is 144 megs.
No, but think about that, 64K of RAM. God, we've gotten lazy in our programming. We just need memory, right? We need lots of it. But the point on this one is the chart, it works really well. It's a great baseline to start, but we allocate 4 GB for the operating system based on the newer operating systems. There's always this choice of whether you use max server memory or min server memory. I've never really seen a case where I would use anything but max server memory on the SQL Server side. You have to give it rights. Lock pages in memory is a wonderful thing. Anytime you can take a production database and lock down what it needs, I'm a big fan of that. Let's talk about NUMA. You want to?
So the idea of NUMA is very simple. You refer to a single socket. And each individual socket, so you might have a 2-core or a 4-core, or such as in a Superdome, a 15-core socket. And then there is certain associated memory with that socket. Optimization, or best practices for optimization, says that if you can fit your VM within whatever socket you have, also meaning NUMA node, you're going to have an optimal architecture. Again, what we have seen in vSphere 6 is the capabilities of going beyond that single socket, or even beyond what we have referred to before as vNUMA, which is the capability of simply minimizing the actual number of NUMA nodes that are touched, as opposed to going to every single NUMA node or socket on a particular server for scheduling opportunities. So we're a lot better at this at vSphere 6, but there's still a value to optimizing, if possible, within that single socket or NUMA node.
And so we use the example here, right? You see the kind of representation of the memory. So if you have 4 sockets, 6 cores, 4 NUMA nodes, 128 gig of RAM, I would argue that every VM, if you wanted optimal performance, should be under 32 gigabyte. Now, what you also have to factor in is there is an overhead to managing NUMA. And what we're seeing is processing speeds have improved about 30 to 40%. So right-sizing those VMs increases the likelihood that this stuff just happens automatically.
It's not prohibitive, it's just optimal.
Right. And the other thing you have to be careful of is if you vMotion to a machine that has a different NUMA topology, all bets are off. Because when it first starts up, that's when it's going to establish the NUMA topology, and it doesn't change unless you shut it down and restart it again. It's going to
vMotion doesn't mean you shut it down. You're moving it, you're transitioning from one to the other. And again, it's not prohibitive. It just could have a performance degradative effect.
So the point here is that in an ideal environment, if you're vMotion, you want to maintain the same NUMA topology, or you could see some funky things starting to happen. Right? How do you check the NUMA settings? This is a quick little search of the VMware log. It'll give you the settings. This is some interesting articles that I think were pretty good in terms of vSphere 6 and NUMA. Anything you want to add to that?
No, just that you don't want to get, this is really interesting to understand intellectually, but you don't want to get too deep into the weeds, because the basic default is that the NUMA topology is inherited from the physical system and read from it. Right? And you probably should just leave it that way, unless you have a specific reason to change it for configuration purposes. But again, optimizing the size of your VM, even if you think 10 cores or 10 virtual CPUs might serve you better, if the NUMA node is 8, you might actually see better performance out of the 8-way as opposed to the 10-way from a virtualized perspective.
The other thing is swapping is always an interesting one. Everybody here should understand what swapping is. Where people get them in trouble is that you can have swapping at the physical host level and you can have swapping at the VM level. And so you can be looking and saying, I'm seeing swapping, and they can be looking at the physical host and not seeing it.
The fastest way to bring an Oracle database to its knees, aside from doing a kill -9 on SMON, is to allow for the SGA, for some reason, to actually swap into temp space. All of a sudden, you're taking a microsecond operation and making it a decamillisecond operation. 4 orders of magnitude in terms of degradation occurred right there.
So the obvious thing is ballooning, memory compression, swapping slow you down. So ballooning is one of those things where I keep hearing people, it's your first line of defense, and it happens at an individual VM level where it's looking for opportunities of a machine that's getting memory degradation to free up memory to help overall performance. It's better to balloon than the alternative. So ballooning is a healthy thing, but it's also a sign of a system.
Which means don't turn off the balloon driver. The defaults in vSphere pretty much are the right thing. So even though you don't want to use it, don't turn it off. Let it be used if absolutely necessary.
Yeah, I see people who think shutting it off, they're just getting themselves into trouble. This is a good illustration of ballooning and sort of how it works. But the thing is, it works at an individual VM level. So it's your first line of defense. That's the whole point here. Don't shut it off. You also have this deduping of memory, transparent page sharing. So if the system's having trouble, it'll start looking at like memory and deduping it, only storing one copy as a way to make things more efficient. It cannot dedupe large pages. We're probably going to talk about that in a few slides. It would then have to take the large pages or huge pages, break them into small pages so they become candidates for deduping.
Go back one slide.
Sure.
Trivia question. You get a free book. Where is that? First person who says, tells me where that is. Where is it? It's Utah. It's Monument Valley, Utah. So whoever it was, you get a free book. I'll sign it afterwards. Okay?
Good. So basically, putting like operating system on the same physical host, these things will naturally work in your advantage. TPS kicks in before the balloon driver. It's always running, always looking for opportunity. Very low overhead. These are not bad things.
Again, just like with the balloon driver, don't mess with the transparent page sharing drivers themselves. There's been, we've kind of solved all of this over the last year and a half or so, but for years there was information out there advising you to turn off the TPS drivers for different reasons. The amount of overhead is absolutely minuscule for TPS.
Yeah, and in fact, this is to drive that point home because we just see people shutting them off and getting themselves.
Don't touch it. No reason to.
This one point, you remember where you talk about being in a shared environment. So oversizing VMs is just going to hurt overall performance. Right-size the VMs. I've seen way too many customer situations where they oversized the VMs and all the performance in the system got degraded. Right. Memory reservations, they rock. They're great. If you have a production database and you reserve the memory, it gets it and no one else does. But that VM will not be impacted by memory.
Except what happens, Michael, if you actually try to start up that VM with a memory reservation and you don't have enough memory to satisfy that reservation.
It's a no-go. It's not going to start.
So you have to know you have it, which includes HAs.
And so when you're trying to think about how much memory to resolve, look at the size of the SGA if it's an Oracle database, add in for the operating system, plus or minus a little bit for the program stack, and that would be the memory reservation. Same idea on the SQL Server side. And I really like this slide because it illustrates that if you have a memory reservation and you look at the swap file at the top, it's 0. It knows that VM is never going to swap. So the hypervisor doesn't even create a swap file. And on the bottom one, you have your traditional swap file that's created just in case it needs to swap. So a memory reservation is an absolutely good thing if you've got the memory and you can lock it down. You'll get better performance. Right, we talked about large pages. The point here is large pages can't be deduped, but using large pages is more efficient. You'll get better overall performance. But if you have memory degradation, it's going to break the large pages into small pages, which is overhead, and then it's going to attempt to dedupe those. You have to set a flag in SQL Server. The whole point of not oversubscribing memory, remember we talked about we showed the HB, and we talked about the fact you have a bottleneck. If the system only has 128 gig, that's all there ever is. If you were to reserve 64 gig, that's locked down for only a certain set of VMs. That means everybody else has to live with the remainder. So just be aware of this as you're locking these things down.
Going back to the right sizing point, know what your real resource requirements are. Map them out to set your expectations accordingly.
Baseline, baseline, baseline. Then you know what you need. Let's talk about the network. Jumbo frames. Anybody know how we got the 1500 bytes? It was like the old typewriter. Anything over 1500 bytes in the old networks, jammed it up. That's why the default is 1500 bytes. Well, you can have, set your packet size up to 8192. If you have jumbo frames end to end, you can get much better performance in your overall environment. The problem is your constriction point. If somewhere along the line the network doesn't support it, it's going to degrade performance as it breaks it down and moves it back up.
If you have 10 gig and you have jumbo frames set up, it needs to be set up, as Michael was implying, everywhere. If it's not set up in one hop, you're going to have a step down, and you might as well not set it up at all.
And so the point is you have up to 9,000 bytes, right? Enable it, especially with IP storage. And do you really want to move data with a big truck, or do you want to move it in small packets? It's your choice. But from a database perspective, enabling it all the way up to 8192, that's the magic number, right? If it supports it, you'll just get much better performance. I've seen 20–30% performance uplifts on this. This is kind of a summary slide. I think a lot of it's obvious. There's some guidelines with the faster networks, but the bottom one I think is the most important here, which is the VMNX Net3 driver.
So it's Power Virtualized Network Driver, just like PVSCSI in at least that thematic sense. Comes with VMFS tools, and you need to use it. It's really that simple.
So this is an interesting one because Microsoft has a cluster validation wizard. And we get into a customer and we say, did you run the validation wizard? And the customer always says, absolutely. The first thing we do when we're troubleshooting the cluster is we run the validation wizard and it spits out that it was all wrong. If it was never set up correctly, you've got these cobwebs in the system that eventually sneak up on you and break things. So it's one of those things that anytime you do anything with the cluster setup, run the validation wizard, put it away. Then if you have a problem, you call Microsoft support, your life is going to be much easier.
And the reason that previous slide is so important is that the support capabilities in vSphere 6 have changed significantly. So we actually can vMotion, what used to be referred to as MSCS, but if my Microsoft MVP friends will get really mad at me using that term. Right? So Windows Server failover cluster nodes can be vMotioned. You still have to use physical compatibility mode RDMs, but they can be vMotioned. Very cool.
So this is a plug for a session out there. It's Wanda Yee and Scott Saylor. Scott is the guy with the bubble. Scott loves really tough questions. So I would challenge you, if you're interested in SQL Server, I think it's an excellent session to go to, and I would challenge you to stump them with your toughest question. You know what's funny? Now this is interesting. We took out 40 slides and we ended 10 minutes early. That gives you a sense of the pace. We were going slow for us.
Michael, you might this time actually be able to open it up for questions.
Oh my God, we have time for
scary,
questions. Yes,
right?
this
You
is
never
good.
know.
And by the way, the deck will be the full deck. There's a lot of great informational slides and some subtle points that we really glossed over here. So questions?
Yes, sir, you first.
I'm slightly surprised. On the storage slide, you didn't mention partition alignment. I'm seeing quite often I/O splits, amplification. Is it still important for virtualized environment?
So the question is about partition alignment, and it's certainly an old classical question. Basically, it's can be a problem if you allow it to become a problem. You really need to, if you create your virtual disks through vCenter, they'll be aligned naturally. And there are other specific storage recommendations for various different storage arrays and so on to deal with that too. But yeah, it's probably something we still should include. And it certainly is addressed in all the best practices documentations. And high-level consultants like Michael down here are constantly going in and making very easy money by fixing partition alignment problems. Because what happens if you have an unaligned partition? Well, you're doing at least double the I/O for at least those particular rates when you don't need to be. Okay?
You know, it's really funny. That was in the original version of this deck about 5 years ago, and we got away from it because a lot of the tools do it automatically now, and we just don't see it very often. It's really an odd problem to see these days. But he is right. It's the old chained row problem. If it's not aligned, one I/O becomes 2 or more I/Os. It can really affect performance, but we don't really see it that often anymore. Questions?
Over here.
Yes, go ahead, sir.
Sorry. You have said, you have talked about difference between RDMs and VMDKs. There is no practical difference in performance. And VMDKs thin provision and thick provision, do you actually see different performance benefits by using thick eager zeroed or even thick lazy zeroed or thin? Do you see a practical difference between them?
So there's a couple of questions in there. The question started off with, I guess, an assertion in a question that I really didn't say that there was no performance difference between RDMs
around 1%,
and VMDKs,
you said.
but it's close. And it has been very, very close. You can look at, basically the bottom line is you ought to be getting about 95% of your physical performance in a VMFS type of environment from a storage throughput perspective. So if you're going out there and you're actually running storage or SQL I/O or just simply D2D operations, you ought to be seeing about 95% with VMFS. With RDMs, you can get still 1 or 2% more, which is why, again, we are using RDMs under certain circumstances of the extreme performance TPCC type of testing. But it's very rarely needed. Most of the time when you use RDMs is because of specific application requirements.
I was just going to say, the vendors provide certain tools that you might be using on the storage array, and that's a valid...
Again, like Windows failover clustering or Windows Server failover clustering. But the other part of the substance of your question had to do with thin provisioning versus thick provisioning. And to a very large extent, that does have to do with the best practices of the array itself. For instance, when we're seeing the use of the flash arrays and so on, there is a very, very small difference at all. Michael's disagreeing with that. Pure Storage and Tintry would totally disagree with his point there. But in fact, they're, for the most part, recommending that we don't be concerned with it for the most part at all. Are you seeing anything different to what I just said?
There's no difference between thick and thin anymore.
Well, yeah, for the most part, there's very, very little, if anything, that's really, especially when you're dealing with the flash arrays. I'm sorry, I thought you were disagreeing with that point. But there are certain requirements, such as you're still with quorum disks and so on, I think, right? That you're still with quorum disks that you still have to use thick provision, eager zero thick, and so on. So if you have clusters, an Oracle RAC cluster, for instance, or quorum disks for Windows Server failover clustering, you still want to go.
It's really specific. It's specific on what is the use that you give for the disk. But
and
generally,
those are mostly functional issues as opposed to performance issues. Okay.
Okay. Just one more. You have said about one-to-one mapping from vCPU and physical CPU. I don't know if this is some kind of a rule or you can try to expand this.
Sure.
Because
So first of all, if it's hyper-threading, I'd say it's 1.2. Give it a 20% uplift.
Okay.
So when you're multiplying them out, and I would say to come out of the gate, be conservative, but once you're comfortable with the environment, I'm okay with deviating from that based on how your environment operates. In fact, the more mature shops deviate, but coming out of the gate, I would absolutely stick to one-to-one, and it would be a very safe way to run your environment.
Because of that, you could not run a lot of VMs. For example, you said that's good to have an isolation of small VMs than big VMs.
Session. This is a database session too, and to a very large extent, our implications have to do with addressing production-level database issues. Okay. And so, as database folks and as production database people, we are concerned with significant performance degradation of any kind. So, your safest and your safest practice and your right-sizing approach is to do this on a one-to-one basis, right? But if you're not really that concerned with your overall performance in general, then the overcommitting paradigm is perfectly effective. Overcommitting meaning, allocate 100 CPUs when you've only got, or 100 virtual CPUs when you've only got 8 there, and as long as you're not really using those servers to a great extent, you're fine.
And where this came from was customers were overcommitted, then they took a production database and everything was working fine in the virtualized environment, put it into the virtualized environment, and everybody got worse and the database never performed well, and then everybody said, oh, virtualization's no good.
That's right.
And so what we've learned is from experience, just be more conservative. I do want to get to some more questions because we're going to run out of time, and we'll be outside. We're not...
You had one question, I don't...
You mentioned our flash array in contrast to traditional storage.
Yeah.
I've always heard great things about their solution with SQL Server. A lot of the SQL MVPs are pretty high on it. I don't know that much about it. I've always heard good things. I've never heard anything bad.
All right, folks, I think we're done. Thank you. We'll be here to answer any questions.